Now we will see important aspects of chemical properties of halogens. So important aspects are reactivity, oxidizing power, their important type of compound namely hydrogen halides, the bond strength, bond length, thermal stability and reducing character, all these are hydrogen halides. We will see one by one. So reactivity, already we have seen that fluorine is the most reactive and least reactive is iodine. So reactivity decreases along the group, fluorine, so high reactivity. Because what is the reason for high reactivity? Bond dissociation energy is low for this fluorine. So that enables the correlation, that is reactivity decreases along the group because of low bond dissociation energy. Next important property is oxidizing power. For this we have to recall the concept of oxidation. Oxidation is the process of removal of electrons. Reduction is the process of gaining of electrons. A substance which can take electrons from the adjacent species can serve as oxidizing agent. A substance which donates the electron to adjacent species, it can serve as reducing. Fluorine will always have a tendency to take electron from the adjacent species. So fluorine is a good oxidizing agent. But iodine, iodide, we have iodide, already we have seen, the outermost electron of iodide has least control over the nucleus. So these electrons are available for reduction. So it is a good reducing agent. So oxidizing capacity decreases from fluorine to iodine, whereas reducing capacity increases from fluorine to iodine. So fluorine is actually oxidizing agent, less oxidizing agent, more reducing agent, ultimate reducing agent. So oxidizing capacity decreases and reducing capacity increases. That speaks about the second nature. So generally oxidizing capacity decreases along the group. Now these are about the individual halogens. Next is the type of halogen compounds. Standard types of halogen compounds are hydrogen halides. XX stands for halogen. Hydrogen halide means HX. So HF, HCl, HBr and HI. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. So here all these are covalent compounds. All these are covalent compounds. But HF is highly, so once again, similar to halogens, hydrogen halide also reactivity decreases. HF is most reactive, less reactive, least reactive. So HF cannot be stored in bottles. If stored in bottles, glass bottles contain sodium oxide. Sodium oxide will react with HF form sodium fluorosilicate. Silicon dioxide and sodium oxide both react with HF. They form sodium fluorosilicate. But HCl can be stored in glass, HBr can be stored in glass, HA can be stored in glass. So reactive HF is most reactive. All are covalent bond. Reactivity decreases from fluorine to iodine in the case of HX. Next, all these properties are of hydrogen halide. Bond strength. You compare the bond strength of HF, HCl, HBr, HA. What is meant by bond strength? Capacity to be remove the iodine or bromine or chlorine from HX. So iodine can be most easily removed, but fluorine can never be removed. So bond strength is maximum for HF, medium for HCl and HBr, minimum for most easily removed. Most easily removed means minimum strength. So bond strength decreases along the group. For bond strength of HX, bond strength of HX decreases along the group. This is automatically, note that bond strength is inversely proportional to bond length. Bond strength, we know that bond strength is inversely proportional to bond length. Lower bond length means high bond strength. Higher bond length means low bond strength, because we know that force is directly proportional to product of charges or masses, whatever be the case, but inversely proportional to the square of the distance. Length is nothing but distance. So if the distance is increased and force is decreased. If the distance is decreased, force is increased. That is why bond strength and bond length are inversely proportional. So it follows opposite trend. Bond strength decreases along the group, means that bond length increases along the group. So they are interconnected. All these appear to be similar. If the compound is reactive, if the element is reactive, its stability is low. If the element is not reactive, its stability is high. Now we are comparing the thermal stability of hydrogen halides. So thermal stability once again decreases along hydrogen halides. HF is most stable and HI is least stable. Thermal stability decreases. What is meant by thermal stability? HI can just be heated to form hydrogen and iodine. But HF on heating, it will not form hydrogen and fluorine. It will not form hydrogen and fluorine. This oxidizing and reducing property already we have seen. So oxidizing capacity is maximum for fluorine, whereas reducing capacity is maximum for iodine. That we have seen. Last important property of hydrogen halides is acidic strength. Once again, HF means either hydrogen fluoride or hydrofluoric acid. HCl means hydrogen chloride or hydrochloric acid. HBr means hydrogen bromide or hydrobromic acid. HI means hydrogen iodide or hydroiodic acid. If they are dissolved in water, they form the respective acid. But the acidic strength increases along the group. So acidic strength increases along the group means HF is least acidic, Cl is least, most acidic is HI. Why it is called least acidic? So far we have seen about it is highly reactive, but now we are telling that least acidic. Why? Acid means proton donation capacity. So proton, how they are donated? So proton is represented as H. So here H plus F minus it will form. But the fluorine is typical. Fluorine takes hydrogen's electron, so it has become F minus. Hydrogen has become H plus. But H plus cannot be easily removed because opposite charges attract each other. So it will also attract electron. It will not also release hydrogen. So it is not possible. It is least acidic. So here I minus iodine will take hydrogen's electron will be removed. H plus will be donated. So acidic strength increases along the group because the acidic strength is lowest for HF because of hydrogen bonding. What is meant by hydrogen bonding? We will illustrate. For all the fluoride, this is the structure for HF. Fluorine is more electric. Consider another molecule of HF, hydrogen fluoride. Fluorine is more electronegative. It attracts hydrogen within its molecule. It attracts also hydrogen from adjacent molecule. So that is why it is called intermolecular hydrogen bonding. It not only attracts hydrogen's electron, it attracts hydrogen atom itself. That is why it is stronger intermolecular hydrogen bonding. So it will not release H plus. H plus is not formed from HF. So acidic strength is least for hydrofluoric. Reactivity is something different from acidic strength. Reactivity, how it affects other materials. Acidic strength means how it donates protons. So it will affect all other materials, but it will not release its proton. It will not release its proton. That is why it is least acidic but most reactive. So fluorine is most reactive, but HF is least acidic. That is to be noted. So these are some salient points about halogens and their hydrogen halides, their significant properties. Lastly, you will see some halogen acids and oxy acids of halogens, their comparison in detail. Now you will see the individual halogens of importance, namely chlorine. So let us see the preparation of chlorine. So chlorine, standard important method of preparation is by the oxidation of concentrated hydrochloric acid. Hydrochloric acid means HCl gas dissolved in water. More amount of HCl gas dissolved in water, it is called concentrated hydrochloric acid. This on oxidation, oxidation means removal of hydrogen. So from hydrochloric acid, hydrogen is removed. So it forms two types of gases, hydrogen and chlorine. Of course they have to be separated. Chlorine gas is a greenish yellow gas, hydrogen gas is a colorless gas. From this you can separate. Next important reaction is by the action of hydrochloric acid on oxide, lead dioxide. PbO2, lead dioxide on reaction with 4 moles of lead dioxide is the solid, hydrochloric acid is the liquid phase, aqueous phase. They react to form lead chloride, which is a salt. It may be soluble or insoluble. Generally it is insoluble, it is precipitated. Water is in the liquid and chlorine evolves. So here all types of material. Lead chloride is a solid, H2O is a liquid and chlorine evolves as a gas. So in every case chlorine evolves as the gas. So this is by the action of same hydrochloric acid on lead dioxide. Then hydrochloric acid is a mineral acid, it will attack many of the substances. Here it attacks lead dioxide, next it attacks potassium permanganate. So it is a redox, everywhere it is a redox reaction. Redox reaction means chlorine is removed from its oxidation state is getting reduced. So KMnO4, here Mn7 plus, MnCl2, Mn2 plus. So KMnO4 is potassium permanganate is reduced to manganese chloride by the action of hydrochloric acid. So it forms hydrochloric acid. So 2 moles of potassium permanganate react with 16 moles of hydrochloric acid, resulting in the formation of manganese chloride 2 moles, which goes into solution as aqueous. This is water. As usual, chlorine is evolved as a gas. So it is a balanced equation, they are not strictly even numbers. So 5 moles of chlorine evolved. So this is the best method for the preparation because maximum amount of chlorine is liberated in this reaction. So these are some of the lab methods. So any preparation is of types. Lab method for demonstration purpose, pilot plant. Manufacture, production on a large scale. So two important named process, manufacturing process for the chlorine manufacture. One is called Weldon's process, another one is called Deccan's process. Weldon's process, manganese salt, there is ore called pyrolusite. Pyrolusite is the ore containing manganese dioxide. So pyrolusite is the ore which contain manganese dioxide. It is a black sand. Pyrolusite on heating with hydrochloric acid. Pyrolusite is a solid, hydrochloric acid is a liquid, aqueous. So they are heated, whereby it forms manganese chloride and water which are in solution phase. Chlorine is evolved as a gas. So it is a manufacturing process. Another one, Deccan's process, it is also based on hydrogen chloride oxidation. Here hydrogen chloride oxidation, it is hydrochloric acid as dissolution in water. Here hydrogen chloride gas is oxidized. It is a gas based reaction at a temperature of about 500 degrees C, about. So it about 450 to 500 degrees C, whereby the Kelvin temperature is 723 in the presence of cupric chloride. CuCl2 is the catalyst. HCl is oxidized. Oxidized means removal of hydrogen from HCl. Chlorine gas is evolved. So steam is formed. It is not liquid. Steam formation is there. It is a gas phase reaction with solid catalyst cupric chloride. So these are the important preparative methods for chlorine. Lastly, the properties of chlorine. Properties of chlorine are divided into two types, physical properties and chemical properties. Briefing about physical properties, it is a greenish yellow gas. It is a good bleaching agent. It decolorizes materials. So it is a good oxidizing agent. It removes electrons from the adjacent species. So it has oxidizing property, bleaching property. Oxidizing property and bleaching property are used. In normal state, it is highly poisonous. So it is mixed with water to form chlorine water. The purpose of chlorine has to be as low as possible. Here it is mentioned as poisonous. Poisonous means not poisonous to germs, but excessive consumption also affects us. So when chlorine is dissolved in water, it forms hydrochloric acid and hypochlorous acid. Hydrochloric acid forms the acidity problems metabolic. Hypochlorous acid is a germicide. So too much of consumption not only kills germs, affects our central nervous system. So these are some of the physical properties of this chlorine. Now we will see the chemical properties of chlorine in detail. Now we will see some important reactions of halogens, generally chlorine. First one, chlorine reacts with sulfur dioxide in water medium. SO2 reacting with the chlorine. SO2, sulfur dioxide, is a gas, chlorine is a gas, water liquid. It forms sulfuric acid and hydrochloric acid. Two mineral acids are formed. This reaction we have already seen many times. This is of important reaction where chlorine reacts with water and sulfur dioxide to form sulfuric acid and hydrochloric acid. Next one, chlorine reacting with hydrogen. The reaction is enhanced in the presence of ultraviolet light and charcoal is the catalyst. It forms, so it is called gas phase reaction. Hydrogen in the gaseous state combining with chlorine in the gaseous state to form 2 moles of hydrogen chloride. In a similar manner, chlorine reacts with sulfur dioxide. This is the reaction of sulfur dioxide with water. Here sulfur dioxide and chlorine, it is called sulfuryl chloride. SO2 Cl2 is called sulfuryl chloride. Similarly, carbon monoxide react, all are gases. Carbon monoxide or sulfur dioxide or chlorine. It reacts with chlorine, it forms phosgene or carbonyl chloride. This compound is called PHOSGENE, phosgene, or it is called carbonyl chloride, CaRBONYL. You are aware of this. This reaction importance will be studied in organic chemistry in detail. So sulfuryl chloride and carbonyl chloride. These are the important reactions. Next one, chlorine reacts with bromide. Chlorine reacts with iodine. So 2 moles of potassium bromide. So this is called a displacement reaction. Displacement means how one element displaces the other from its compound. Here chlorine displaces bromine from potassium bromide. So it forms potassium chloride, goes into solution, bromine is separated, displaced. Similarly, chlorine displaces iodine from its salt. It forms potassium chloride. Here also it forms potassium chloride and iodine. Here already we have seen that bromine is a liquid, iodine is a solid. But no question of liquid or solid, displacement. So chlorine displaces bromine and iodine. Generally, lower halogen displaces higher halogen from its solution. Whenever you speak a rule, in the case of halogens, the exception is fluorine. None of these reactions, they are not writing fluorine. Fluorine is highly reactive. This separate. Fluorination leads to explosion. That has to be separately studied. Many times we have seen in this. So next is the displacement reaction. Last type of reaction is the action of alkali, that is sodium hydroxide or potassium hydroxide. Alkali reaction is of 2 types. Alkali in the cold condition as well as dilute condition. Alkali in the hot condition as well as concentrated condition. So chlorine reacts with dilute cold alkali to form 2 types of salts. This is called NaCl, is called sodium chloride. whereas this is called sodium hypochlorite. We will see the hypohalous acid later. The salt is sodium hypochlorite. It is not hypochlorite with water. Whereas the same chlorine, when it reacts with hot concentrated means 6 moles. Here only 2 moles. Dilute means 2 moles. Cold, hot concentrated alkali. Here it forms sodium chloride, and this is called sodium chlorate with the formation of 3 moles of water into liquid. These are some of the important reactions. Now we will see some halogen oxy acids and their importance in brief.